Okay, welcome. Thanks for coming to the week 3 webinar. So hopefully, hopefully you're getting through the course, so we're not at the very beginning anymore. But let me tell you the plan today. The plan today is I'll start out by just a second. I'll start out by answering any questions that you might have, as always. And then after that, I'll do a little review of what it means to be a discrete variable and what it means to be a continuous variable. We actually talked about that in week 1, but this is the week that we're really going to use it. So a good review is important. Then we'll talk about probability distribution tables, how to create a table of values and probabilities. Then we'll get into the expected value and the standard deviation for a discrete distribution. Really important, comes up in lots and lots of applications. Then we'll get into the binomial distribution. That's a special kind of distribution. It's actually the first kind of distribution that we'll talk about in this whole class. We have a lot of distributions to talk about in this class. Actually, I guess we kind of talked about the normal distribution, but not deeply. So we'll talk about the binomial distribution, and that's a distribution of how many yes answers there are, basically. And I'll talk about that in more detail in a little bit. Okay, then we'll talk about continuous distributions. So when you have a continuous variable and you want to talk about, well, how do you understand that distribution? It gets much more complex. Then we'll get into a very specific case of a continuous distribution called the uniform distribution, which it's not necessarily the most important, but it is the easiest to understand. So that's why, since this is the beginning of distributions, it's good to start easy, and then we'll move on and definitely get harder after that. So we can understand it. We can actually do the math very simply, and you'll see how that works. And then finally, we'll talk about the mean and the standard deviation of a uniform distribution. And I'll give you the formulas. I'm not going to prove it.
Recording in progress.
Do a lot of math, but it is important to have those at least close to. You don't have to memorize it, but have them available. So that is the plan. I want to give you a reminder, and that is you should be making lots of good progress on Project One now, because it's not that many weeks now until it's due. So don't wait till the last minute. And one thing that I strongly recommend is look at the Project One discussion board posts where people came up with their ideas and look at my answers so you know what works and what doesn't work and what needs to be changed and what you can do for yours to make it better. And then when you're ready, if you haven't already done so, when you're ready to you have an idea of what your survey question might be, how you're going to do your sampling technique, who your client is, what the population is. Post that on the Project One discussion board so that I can give you comments and help you out. I want you to do well, but it's very important that you do things like post your ideas so that I can help you do well. If all you do is try and do it all by yourself, or you and your partner, then it's much harder. So I, definitely recommend, getting that help by posting on the Project One discussion board, and then I'll make sure that I'll answer your questions. And what I found is those that have already posted, you have some good ideas, but definitely modifications needed to be done. And I'm trying to help you with that. So that is the plan. Are there any questions at all about the class, about what's going on? Any questions? Feel free to post in the chat box. Any question you have, I always have an eye in the chat box, so I make sure that I'm watching it. Okay, if there's no questions, then let's get into statistics. Okay, and by the way, this week we have 2 chapters, chapters 4 and 5. That doesn't necessarily mean it's a harder week. Chapter 3, I think, for most people is hard. harder than 4 and 5 combined. But doesn't mean you shouldn't pay attention. So it is important that you get this stuff down. So let's go ahead and remind you these definitions. So a discrete variable is a quantitative variable whose set of outcomes can be displayed as a list. So you can display them, you can write down the possible answers as a list. Sometimes a list will go on and on forever, but you'll at least be able to like kind of list them with commas and then continue. So that's when you know it is discrete. Okay. Quantitative variables that are not discrete are called continuous. Okay. So if it's not discrete, it's continuous. Okay. The formal definition, by the way, you need to be a math major for, so we're not going there. I'll be saying that a lot, by the way, but I want you to get the idea of it and to see lots of examples on what discrete and what a continuous variable might look like. Let's see if you can post in the chat box one example of a survey question that would have a discrete variable that it is where the answers will be, and one that will be a continuous variable where the answers will be. Okay, make them simple. You don't have to make them too hard. See if you can post in the chat box kind of your idea of what an example might look like. That way it'll make sure that you're actually paying attention and getting out of it. You get a lot more out of it if you're involved. So see if you can post in the chat box a survey question that has a discrete variable as an answer and one that has a continuous variable as an answer. See if you can post some. And I can mention some too as you're posting. So for example, a discrete variable might be how many siblings are in your family. Okay. You can list, including yourself. You can list all the possibilities. There could be one, because there's you. There could be two, there could be three, whatever. Okay, how tall are you exactly is actually not a discrete variable. That's a continuous variable. For example, in terms of how tall I am, let me just let you know. I am 5.7354321 dot 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 dot. So there's just no way you can list all the possible heights. Does that make sense? Okay. How many pets do you currently own? Okay. So the question is that discrete or is that not? You should mention that. Yeah, that's discrete because you can own 4 pets, you can own 8 pets, but you could list all the possible pets. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, dot, dot, dot. Okay, and that lists all the possibilities. Does that make sense? Whereas exactly how tall are you cannot list all the possibilities. Okay. I did. I'm looking at the chat box and hoping that everyone's putting things in. How many cups of coffee do you drink per day? You didn't say whether it's discrete or not, or continuous. It's a survey question, but which is it? Yeah, that would be discrete if you're assuming that, you can't drink 1.735 cups. Okay, so if you call a cup that's only half full a cup, then that's okay. On the other hand, if instead of how many cups of coffee do you drink per day, how many ounces of coffee do you drink per day, that would be continuous. Does that make sense? Or how much coffee? Any questions on these ideas? So how many is kind of the grammar we use for discrete, and how much is the grammar we use for continuous. And that sometimes helps you kind of understand that. Any questions on discrete versus continuous? Okay, so now let me give you an example of a discrete distribution, but now we're actually going to do a whole lot with it. Okay, so here's the deal. I try to give kind of real life examples. A car salesperson gives out a $10 gift to every customer who test drives a car. Okay. That happens sometimes, right? If you test drive if you go in and say, yeah, I'll test drive the car, they give you a little gift. Okay. Hoping you're happy and maybe you're gonna, buy the car. And let's suppose that 12% of all customers who test drive a car purchase the base model of the car, resulting in a $200 commission for the salesperson. Okay. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. Okay, this is definitely discrete because in this case, there are only three different things that could happen, three different values. Okay, one thing that could happen is the person test drives the car and the salesperson gets a $200 commission. Okay. And note, by the way, if you're interested in profit, then it would be $190, not 200. Why is it 190? Any ideas? Instead of 200 for profit? Yeah, you're giving away $10 out of but you get 200, so you're profiting 190. Okay. On the other hand, another thing that could happen is they can buy the deluxe model. And then your profit is 290 because it's 300 minus 10. Okay, there's a third thing that can happen. What's the third thing that can happen? Actually happens most of the time. So one profit would be 190, one profit would be 290. What's the third profit? The third profit would be negative 10 because you're giving away a $10 gift. You have to spend that $10 and you don't get anything. Okay, so sometimes negative numbers happen. Any questions on that idea? So what do you think? Do you think this is a good job? Think it's high paying? Do you think it's low paying? What's your guess? Okay, and the answer is you may not be ready to guess yet because you haven't had the statistics. So we're going to have to see, and we're going to do some probability calculations, and we're going to see if it's a good job or not. Okay, so here's what we do. So we're going to look at the profit first. So what we're going to do is we're going to look at the values of x being the profit that could happen. And what we said is one value of x is 190. A second value of x is going to be 290. And a third value of x is negative 10. Those are the only possibilities, right? With this scenario. And then what we do is we find the probabilities. Okay. The first probability of getting $190, well, 12%, hopefully you know probabilities are always decimals, not percents. But how do you change 12% into a decimal? See if you can put that in the chat box. Some very basic math. Yeah, 0.12. Okay, you could put 0.12. If I type that, then it's sometimes hard to read, so I put the 0 in front. Okay, and then we have the 290. That's 8% of all customers. 8% chance. How do you write 8% as a decimal? Yeah, 0.08. Okay, and then we got to do the negative 10. And here's how we get to the negative 10. We use the fact that the total probability of anything happening, if you add them all up, you have to get 1. Okay, that's one of the big definitions of probability is that the sum of all probabilities has to be 1. So that means that 0.12 plus 0.08 plus what we don't know, let's call that P for probability, sounds good, equals 1. And now I get to do a little bit of math. So 0.12 plus 0.08 is 0.2. 0.2 plus P equals 1. Any questions on this little basic math that we're doing? We do have some math to do today, by the way. So what is P? One last step in math, see if you can do it. Yeah, 0.8. Any questions on finding the probabilities? Any questions? You could check out that 0.12 plus 0.08 plus 0.8 really is 1. Okay, any questions on that? Yeah, it's not the law of continuity, it's the law of probabilities. Is what it's called. Okay. So the next thing we typically do is we're going to create a probability distribution table. So we're going to take what we just figured out and we're going to make a table out of it. And here's how the table works. It is going to have 2 rows. The first row I'm labeling as X. The second row I'm labeling as P of X, so probability of X. And then I put down the values of X, 190, 290, and -10. And I put their respective probabilities, 0.12, 0.08, and 0.8. Any questions on that? Easy enough? Have I lost anybody on the bit of math that we did? Okay, what we want to do is we want to say, what do you think the profit is going to be over the long run per customer? And by looking this, any guesses on what the profit might be in the long run per customer? You notice most of the time, person's losing $10, but the few times they don't lose $10 are gaining a lot of money. Any guess? Just throw a number in the chat box and see what your guess might be. What do you think the profit might be over the long run? Let's see you guessing. Maybe you're afraid to guess. I'm not sure. Okay, so let me go over a little bit of vocabulary where in statistics we use 2 very important words to talk about that kind of probability in the long run idea. Okay, and it's called the expected value. Okay, very important. So it's called the expected value. And I have a template for it. If many trials are done, then it is very likely that the average of the trials will be very close to the expected value. Let me ask you if you get to have an idea. Why did I say those specific words very loud? Many, likely, average, and close to. Why did I say them loud? And I think this is the first time I've done this. It's not the last time. I don't see y'all jumping in with ideas. Okay, so maybe I'll tell you. Because if you don't use those words, I'm going to take off a lot of points on your exams, your discussion board, assignments, all that stuff. So write this down right now. Make sure you use those words. But the good news is if you do use the words, you get a lot of points. So it's not an ouch because you can get the points. If you don't listen to the webinar, then you won't even know to put the words in. If you use AI, it's not going to know to put these words in and you're going to lose a lot of points. So if all you do is get AI to do your work for you, it is not going to work. Okay? It's one way I keep that people from just using AI to do everything. So it is a requirement to watch the webinars. So if many trials are done, then it is very likely that the average of the trials will be very close to the expected value. Okay. Now this is a template. This is a template. This is not the exact wording in terms of all the words, just those that I yell, those have to be there. The others are going to be related to what it's asking. So don't just write exactly this. Okay, so I'm going to find the expected value. I'm going to say it quickly in terms of the formula because you don't need to know it. But the expected value is a summation from I equals 1 to n of x times p of x. Okay, you don't need to know that. But any guess if we want to find the expected value, how we're going to do it in our class? Any guess? Instead of using that formula. Yeah, we're going to go to the calculator. So let's go to the calculator. I tried to make this calculator really easy to know what to do if you know what you're working on. What calculator number do you think we're going to use? This should be very obvious. And I also put it in the order in which we do things in our class. So we have 24 calculators. Yeah, number 6, because we want the expected value, and it says expected value. And we're going to want the standard deviation too. So, and standard deviation. Just to note, I made this vertical instead of horizontal as a table, and that's because it fits better on the screen. So that's why I made it vertical. So just let you know that. And it asks to put the x's and the p of x's in. And notice the x's are 190, 290, and negative 10. So we go 190, 290, and negative 10. And the p of x's are 0.12, 0.08, and 0.8. So 0.12, 0.08, and 0.8. Okay. I do want to note in the instructions, it says do not include commas in your entries. So if you needed expected value and you had really big numbers, like, 100,000, don't put a comma to separate the numbers. Just don't use that comma. Okay, just write down the number without a comma in it. Otherwise, the calculator has troubles. Any questions on how I type this in? I tried to make it easy. And then I hit the calculate button and it just gives it to me. The expected value is 38. So let's write that down. So expected value is 38. And the standard deviation is about 98.5. Let's go 2 because it's money. 98.47. So we're talking about dollars, 98. $98.47. Because this is about money. Okay, whereas the expected value didn't have decimals, so it's just $38. What do you think? Is it a good job now? And by the way, I'm not a car salesperson. I've never done that. I don't know how long do you think it takes to work with a customer and have them test drive? What's your guess? I have no idea, so just guess. I would just guess too, but this is not a stats question. How long do you think it takes on average? Okay, so if it takes an hour, then the expected value, then you can say kind of in the long run, we're talking $38 an hour. You know, Not terrible, not great. No, it doesn't take 2 days to work with someone test driving a car. It's not 48 hours of actually spending time with them. That's for sure not. Does that make sense? An hour I'll give you. Half an hour is fine too, but not 2 days. Okay. Yeah, if you think it's 10 minutes, then so if it only takes 10 minutes to test drive a car and work with a client, then you're talking about 38 times six. That'd be really good money. We what 248 $48 an hour. Okay. But I don't think it takes only 10 minutes to work with a customer. But I'm just guessing. I'm not a car salesperson. All right. So now we can interpret it. So here's the interpretation of the expected value. If many customers come and test drive a car, then it is very likely that the average profit that the salesperson will make per customer will be very close to $38. Any questions on the expected values interpretation? Okay. I want to make a note because some of you had trouble with the exam actually, is that, if the question was asking about test driving a car, you need to be writing about test driving a car, not just the template and that's all you do. Make sure if you're explaining something about a question where it was about test driving a car, you better be referring to test driving a car and not just writing the template. Does that make sense? Because some of you in on the exam question just wrote a template and didn't refer to what the question was asking. Okay. And similarly on this, you need to be talking about customers and test driving a car and profit, salesperson. Do you see how that stuff works? Any questions on the interpretation of the expected value? Maybe I'll write EV interpretation. Okay. Now the standard deviation, $98.47. What do you think? Is that a lot or a little? Yeah, that's a lot. So, the expected value is 38, and the standard deviation is much bigger than that. So there's got big fluctuations going on. So the standard deviation is high. Okay. Standard deviation is high. So if you have such a high standard deviation for a job for the amount of profit you're making, then there's going to be days where you're actually losing money. And there'll be days when you make a killing amount of money. Does that make sense? Or much more money. So if that's the case, what you should do is make sure you have money in the bank to afford basic needs for the days when the salesperson loses money. That salesperson better have some extra money. Otherwise, there may be a day where salesperson makes nothing or actually loses money. And if there's no money in the bank, then you don't have enough money to go to the grocery store. Any questions on that idea? So it's very important to understand what the standard deviation shows you versus what the expected value shows you. Okay, the expected value is that average profit in the long run, and it won't be exactly that, but it'll be likely to be close to that amount. Any questions on that? Any questions? Okay. Let me give you a personal example where I actually use the expected value. And I know this is going to be sounding weird, but I actually made the news. Any guess? You probably won't guess. Okay. Uh, so just let you know, This is Tahoe, where I am right now. That's where I live and where I teach. Besides skiing, what's another big industry in our in Tahoe? Gambling. So I actually taught a course called the Mathematics of Gambling, and I asked people, I asked the students, well, tell me about themselves, and I had a student. She said she worked at the casinos. I asked, what do you do? And she actually was in charge of the whole, not just that casino, but the whole state and of many, 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 many casinos. And she came to me during a break and she said, well, I went and talked about the expected value for a particular game. I'm trying to remember which game it was, but it was a particular game, and the expected value for the casino was around around 8%. Okay, so if somebody, if lots of people spend, if lots of people spend $10 or $100, then it's likely that on average, in the long run, that they will lose $8 per person. Does that make sense? And that's how the expected value works. That's how you interpret it. And I explained that. And she came to me during break and she said, this can't be right because we're losing money at our tables over the last 3 months. And that's many, many, many games. And you said that you're supposed to be really close to the expected value, which means winning money. Any thought on what I told her? Okay, if you don't know, let me tell you. I told her that what you're saying has less than 1 in a trillion possibility of happening. Okay, I'm not going to get into all the calculations, but you can trust me on this. So you need to look at the cameras. Someone's cheating. And the news came out a couple days later. There was a ring of cheaters, and they were literally working together, the casino players and the casino dealers, so that the players would all make money, and then they would give money to the dealers, and they caught them and they put them in jail. Okay, and I was the mathematical part of the reason for catching them. So that really happened. Inside job. So using the expected value, really can happen in the real world. Okay. That was one particular one that I have done in the real world. Another expected value that I use is stock market. And that gets complicated. I make a lot of money that way. Because if I can get a positive expected value, then I'm going to make money. Does that make sense? So the expected value is really good for making money. And it does all kinds of other things too, besides just making money. Okay, but this is real. Okay, so let me give you another example. All right, let's suppose now you've been offered a life and dismemberment insurance policy that costs $1,000 per year. Okay, I'm not sure. Do you guys know what dismemberment means? Yeah, so that means like you had some accident and maybe your arm got chopped off. It's some really terrible thing with your body. Okay. Losing a limb, things like that. Yeah. Having your eyes cut out, dismemberment's bad. Okay. And that's why you get insurance policies can pay for that. The policy pays the heirs $100,000 in the event of death. Obviously, if you die, you don't get paid because you're dead, but your heirs, your children, or your spouse, whatever it might be. Okay. And $50,000 in the event of dismemberment. Okay. And for dismemberment, they pay you, not your heirs, because you're alive still. Okay. The actuaries have determined that you have a 0.3% chance of dying this year and a 0.5% chance of dismemberment this year. Find the expected value in the standard deviation. Interpret the expected value, then explain why the standard deviation might indicate that it still might be a good idea to purchase insurance, possibly. Okay, so same idea as the last one, but it's just a very different example. Okay, so in this case, the insurance policy costs 1,000. If you die, your heirs get 100,000. So that's 99,000. Okay, and I want to let you know for the calculator, don't put a comma. Don't put 99 comma 000 or it'll mess up. Okay. If you're dismembered, it'll be 50,000 minus 1,000, which is 49,000. And if you don't die and you're not dismembered, you lose $1,000 because you had to pay for the insurance policy, you didn't get any money back. The probabilities are given, 0.3% chance of dying. So remember, you got to move the decimal over 2 places. So if you do that, you get 0.003. And you have a 0.5% chance of dismemberment, or 0.005. Okay, if we take 0.003 plus 0.005, you get 0.008. 1 minus that is 0.992. You don't have to do it in your head like I did. You're always allowed a calculator. Any questions on creating this table? Okay, so then we go ahead and we use a calculator. I think the easiest thing to do at this point to get rid of all these numbers is just hit refresh on the computer. And now it blanks out everything, and that means I can start over again. So our numbers were 99,000, 49,000, and negative 1,000. And remember, no commas, no commas. And the probabilities were 0.003, 0.005, and 0.992. Let's pretend I made a typo. So 0.997. Let's say you made, or let's say, how about 932? Let's say we made a little typo. And we tried to use calculate, then it won't give the right answer. So you got to get it right. So don't make a mistake. So now we calculate, and the expected value is negative $450. The standard deviation is $6,495.96. Okay, and these are dollars. So what the units are here. So would you be surprised if the expected value is negative? What do you think? Or would you expect the expected value to be negative? What do you think? Yeah, you definitely expect it, because if the expected value was positive, then the insurance company would go out of business because they have many, many customers. So for them, there really is many, many in the long run, and they're going to end up they're going to very likely end up losing money if the expected value is positive, because that means everyone's making money on average. Do you see that? So the expected value should be negative. Okay. And the standard deviation is really big. Again, we should expect that, by the way. By the way, would you rather make 99,000, 49,000, or lose 1,000? Which of these three would you rather have? Okay, you better want to lose money. If you want to make 99,000, that means you want to die. So then I need to, tell you about the counseling services we have. So, with insurance, you want to actually waste your money. That's what you're hoping for. Does that make sense? All right, but so if the expected value is negative 450, should you just not buy insurance? Okay. So the answer is it depends. It depends on how disastrous it would be if you died financially. So if you have no one that actually cares about that needs your money, like if you're not working, if you're just a student, for example, there's no reason to have life insurance because if you're a student and you die, no one's going to get hurt financially because you died. Do you see? On the other hand, let's suppose, you're making money and you have two small children. If you died, then all of a sudden those children don't have any money. So that would be terrible. Do you see that? So, and that standard deviation is high, which means it might be worth it. So it may or may not be worth it. Okay. And to interpret the expected value, you would say if many customers bought life insurance, then it would be very likely that on average, the amount of lost money per customer would be very close to $450 per customer. Any questions on that? Is that clear? Okay, so now it's time to move on. We just finished chapter 4, and now it's time to move on to chapter 5. Chapter 4, by the way, is about the discrete distribution and expected value and standard deviation. Chapter 5 is, sorry, we're still on chapter 4, but we're at the end of chapter 4. Chapter 4 has two pieces. So the other piece of chapter 4 is what's called the binomial distribution. Okay, and this is very important. There are many, many, many times you'll hear survey questions where they're yes, no questions. Okay, you only have two choices, yes or no. Okay, so a binomial distribution comes from a multiple independent trials of a yes, no question and measures the number of yes answers. So let's suppose, for example, you were maybe working for the news and you wanted to find out whether or not people are happy about Trump's tariffs. Okay, whether that's a good idea, or a good thing or a bad thing, having tariffs, because that's something that Trump has been doing. Okay, if you don't know that, then you've been really not watching news. Um, so a survey question would be, are you happy that Trump has put tariffs on, other countries for goods that, come into America? Okay, and so that survey question, the answer would be yes or no. Do you see? Either you're happy about that, you think it's a good idea, or no, I'm not happy, it's a terrible idea. Okay. By the way, one thing I don't do in this class is I don't tell you who you should vote for, or, I don't push you one way or another in politics, but I do want you to understand the news and how to understand when data is collected and understand whether it's reliable and what it means and all that. Okay, so that's why I'm giving this example. Okay, the last thing I'm going to do is tell you, who to vote for. um, but I will tell you if you're a citizen, you should definitely vote if you're a citizen. If you're a citizen and you're 18 or older, that's it. That I can tell you. Okay, so you'll notice that that's a yes/no survey question, and you're asking many people. Okay, and then if you do things right, they're independent. Independent. Okay, you're making sure that you're not doing any kind of, one person hears the other one and they're probably going to say yes because the other person said yes. You make sure that kind of stuff doesn't happen. So that's what that independent means. Okay. So any questions about what a binomial distribution in a yes/no survey question is? All right. So here is a very important example. I'm not gonna do the Trump one. I want to do something that to me is even more important. Okay. And that is climate change. Okay. Maybe you're a denier of climate change. I hope not. But let's find out. If you're a denier, we'll find out whether, it's reasonable to not to deny it. So let's take a look. Okay. And I actually did this research. So there have been 175 years in recorded history of global temps. So for the past 175 years, we have been actually getting the global temperature. Before that, we probably didn't have the technology to do it or the effort or whatever. But we actually been getting global temps for 175 years. Okay. And the way you do that is you measure temperature all over the earth and then you write down the values. Okay. So here's a question. In the next 20 years, so basically between now and 2045, if the weather is random, find the probability that at least 10 of them will be in the top 10 of the prior 175 years. Any questions on this question? Anyone confused about what this is asking? Okay, so notice you can consider this as a binomial distribution because next year we're going to take the temperatures, we're going to find the average temperature on Earth, and we're going to say, is that the highest temperature in the past 175 years? Does that make sense? And it'll either be yes, it is in the top 10, not just the highest, but is in the top 10 in the past 175 years. And either it is in the top 10 or it isn't in the top 10. Any questions on that? And then the year after, we'll do the same thing. And either that one is in the top 10 or that one won't be in the top 10. So each of those years is going to be a yes/no question about being in the top 10. Okay. We're assuming randomness. Okay. And by the way, I really want to focus on this because it's very important in this class. What are the first three letters of assume? Yeah. So a lot of times assuming makes an ass out of you. And assume ends in an E, by the way, for the word assume, and me. So that's one way of saying it, is you don't want to have to assume, but we're going to assume. Does that make sense? I don't know if you ever heard that, but assume means you make an ass out of you and me. It's not a good thing. So the first thing, let's find N. Okay, well, we're going to be looking at the next 20 years, and each of those 20 years is either going to be in the top 10 or not in the top 10. Okay, so that is going to be 20 for N. N, by the way, that letter always stands for sample size. Got it? And the probability of being in the top 10 will be 10 out of 175. That's the probability of being in the top 10 of the last 175 years. Any questions at all on finding N and P? Okay, so now, let me bit so we can see it all. We want the probability that X is greater than or equal to 10. Because we want to say what's the probability that at least 10 of them will be in the top 10 of the prior 175 years. So I just want to let you know, because it's going to help with the calculator. The smallest number to make this work, to have at least 10 in the top 10, what's the smallest number to make this work? Should be very obvious, by the way. Not one. If you only have one in the top 10, you don't have greater than or equal to 10. 10. 10 is the smallest number that's greater than or equal to 10. Okay. What's the biggest number that's greater than or equal to 10 that could happen? Uh, no. 20. Because we're looking at the next 20 years, and if each of them is in the top 10, one at a time, by the way, then that would be the biggest, most you can have would be 20. Any questions on that? And now trials is 20, because that was N, and P is what we want. So this is another example where I'm going to tell you that trust the calculator. If you want to learn how to do this, in terms of mathematically, then you need to change your major and be a math major. Or maybe you're already a math major, but then you'll learn it. But trust the calculator. And by the way, I coded the calculator, so trust me. And I was a math major, by the way. That is what I do. So now I'm going to go to the calculator. I'm going to go back. We can't use this one anymore. This is not expected value. Not what we're looking at. We go back to the calculator menu. And what calculator number should we use? Should be obvious. Yeah, 7. Notice we're doing things in order. Right after expected value is binomial probability. Okay, and then it asks you for the low, the high, the trials, and P. The low, if you remember, was 10. The high was 20. The trials were 20. And I am going to click P. I'm going to hit calculate. Oh, I'm sorry, we need P also. And the probability, got to put that one in. So P was 10 out of 175. So let's get 10 out of 175. I'm going to get the scientific calculator. Oops, that didn't work. 10 over 175. Yuck. One more try. 10 over 175. And it gives you this number that is 0.05714, etc. I'm going to just copy that, paste that into the P. Now I'm ready to hit calculate. Notice it gives me 0. Okay. And the reason it doesn't mean it can't happen, but it is such a small probability that it rounds to 0 even to like 20 decimal places. So our probability was 0. What does that mean? So let me just tell you something. In the last 20 years, let's say the last 20 years instead of the next 20 years, how many of the last 20 years do you think have been in are the top 10 of the last 175 years? Okay. It turns out all 10 of the top 10 of the last 175 years have happened in the last 20 years. Okay. But if the probability is 0, that means it shouldn't be able to happen. So what does that mean? What does that mean? If it can't happen and it happened, what does that mean? Did I tell you? Right here. Assume randomness. Okay. It's not aliens. Assume randomness. That means assuming that truly every year has been randomly, the temperature is random is wrong. So then you go back and you realize something is wrong. And what you realize is we don't have randomness. We have a cause of temperature increasing. Does that make sense? Okay. And this is basically a mathematical proof that we have global warming. Okay. That our temperature is higher. Does that make sense? Okay. It's very important to understand how to use statistics, not just how to calculate it. And that's how you use it, is that if you get something like that, then you find out what was the assumption. The assumption must be wrong. It's not random. So if it's not random, that means we really are having global warming. Do you see? So it's not a 10 in 175 chance of next year, for example, being in the top 10 because it's not random anymore. Any questions on understanding, really understanding science? Any questions on this idea? Okay, we're going to be doing this a lot in this class. We're going to be looking at these probabilities and saying, hey, if you have such a tiny probability, then let's go find out what's wrong. And what's wrong here is we assumed random, and it's not random because we're making things increase instead of it's randomly going up and down. Any questions on that idea? Okay. All right. I'll do some of these a little bit quick because we don't have that much time. Okay. 24% of people worldwide feel lonely. I read this in a recent survey, by the way. Okay. If 17 randomly selected people are surveyed, what's the probability that between 5 and 10 of them feel lonely? Okay. So we just go here. I'm going to refresh. Low is 5. High is 10. And we're looking at 17 people. And we said that 24% of people feel lonely. So 0.24. And we calculate. And there we go. Any questions on the fact that there'd be a 38.75% chance that between 5 and 10 of 17 randomly selected people would feel lonely? Okay. How about at least 6 of them feel lonely? Okay. So what I found that a lot of times the difficulty of these is reading the words, and from that getting the high and the low, or the low and the high. What if it's at least 6? What's the low? Yeah, the low would be 6. What's the high if it's at least 6? 17. Good. And then we can click it, and that's about a 20% chance. Fewer than 5 feel lonely. What's the low for fewer than 5? 0. 0 is certainly fewer than 5. What's the high for fewer than 5? It's not 5. 5 is not fewer than 5. Very important to know that. Yeah, it's 4. 4 is fewer than 5. 5 is not fewer than 5. 5 is exactly 5. Do you see the difference? So I want to do this because a lot of people make that mistake. So don't make that mistake. And then I click it, about 61% chance. Exactly 5 feel lonely. Oops. What's the low for exactly 5? Yeah, 5. What's the high for exactly 5? Still 5. And hit calculate, and it's about an 18% chance. Any questions on this example? Okay, let me move on. And we're going to talk about continuous distributions. So remember, continuous distributions mean you can't list all the possibilities. So you can't make a table, by the way, because you can't list it. If you can't list them, you can't put them in a table. So what you usually do is make a graph. So this is a graph with a normal distribution, by the way. And let's suppose that we wanted to find out the probability that x is between 1.8 and 2.75. And this is what the graph looks like. Then what it turns out is that if you happen to have a continuous distribution and you want to find out a probability of x being between two numbers, it's the area under the curve of that distribution function in between those two numbers. So it's this shaded in area. Okay. Do you know how to find if this was a normal distribution, what that area is? Yes or no? And for yeses or nos, do you know how to find the area with this example? Okay. All right. So let me just put it this way. And let's suppose this is a uniform normal, this is a standard normal distribution. So the answer is, if you do know how to find it, that means you've already taken statistics. And if you know how to find it by hand, that means you're a math major. So it's very difficult, by the way. So no. So what we're going to be doing today, is we're not going to do this example. We're going to do the easiest example, and that is the uniform distribution. Okay, so now we're moving to chapter 5, by the way. So a uniform distribution from A to B is a distribution such that any two given intervals of length k that is contained in A to B has the same probability of occurring, and any interval outside of AB has a zero probability. Okay. And the distribution curve for a uniform distribution is a rectangle. Just trust me on that. Any questions on this definition? Okay. The notation we're going to be using, it's very important you know this notation, is x. You know what this symbol is here? It's on your keyboard, by the way. So it's not a hard one, actually, to type at least. What is that symbol? I don't know how to say it. Most people don't know how to say this symbol. It's the same symbol, by the way, if you speak Spanish, that little thing above that N in enye. Um, that's called a tilde. It's called a tilde. So if you haven't heard that word, you know it now. That's not a math word, by the way. That's just called tilde. Okay. So, and the way we're going to read this is not about, we're going to say X has the distribution. That's how you read this tilde, or has the distribution, and then U. Any guess on what U stands for? This should be obvious. So uniform, yeah, it's obvious because it's the other thing in red on this example. So U stands for uniform. It's first letter of uniform. So we typically don't write the whole word uniform. You just write U and then A comma B, and that's how you write that X has a uniform distribution with bounds A to B. Any questions at all on this uniform distribution idea? Okay, so it's important to be able to do examples. Okay, so here's an example. Suppose that the time that students spend with a math tutor is uniformly distributed between 10 and 120 minutes. So we would write x tilde u, 10 comma 120. Any questions on that? By the way, if I say suppose, it means I'm making this up. But, it might be true. Any questions so far? Okay, if a randomly selected student who used a math tutor is observed, find the probability the student will spend between 30 and 70 minutes with the tutor. Any questions on the question? Okay, so the way we do this is we draw a picture. And here is the first picture. And that is, remember, a uniform distribution is a rectangle. And we're going from 10 to 120. So the left-hand side of that rectangle's x value is 10. The right-hand side's 120. And the rectangle is going to have a height. We don't immediately know the height, so I'm just going to call it h. Sound good? Okay, we want to find h. That's the first step in doing this. We need to find h. So the way you find h is you realize that the probability of something between 10 and 120 will be 100% chance, because you can't be out less than 10, you can't be greater than 120 if it's uniform between 10 and 120. So what we can write, let me, put down then. Is we can say the area of this rectangle, that's the probability of being between 10 and 120. That is the base times the height. That's how you find area of a rectangle. And that must be 1 because you have a 100% chance of it being in the rectangle. And the base is going to be 120 minus 10. How far from here to here? From 10 to 120, you just subtract the two numbers. The height is h. 120 minus 10 is 110. So we know 1 is equal to 110h. We divide by 110, and you get h is 1 over 110. So I did warn you at the beginning of the webinar, this week does have a little bit of math, nothing like advanced math, but a little very basic algebra where you have to solve for h. Any questions so far? Okay, then we want to find out the probability that the person's going to spend between 30 and 70 minutes. So now I'm going to add to the picture the numbers 30 and 70, and the probability will be the area between 30 and 70, or the area of this smaller rectangle. Do you see how that works? So the probability of being between 30 and 70 will be the area of the smaller rectangle, which is b times h, base times height. The base now will be 70 minus 30. It's the high minus the low. The height we already found was 110. So the height's 110. And when you multiply those out, you get 40 over 110. Any questions? Any questions at all on this example? I do want to let you know, just a heads up, when you're doing the exercises on the computer, read the question. If it says write it as a decimal to 4 decimal places, then make sure you stick in a calculator and you go 4 decimal places out. If it said write as a fraction, write as a fraction. So whatever it tells you to do, do. Is that clear? Okay, so then there's the next question is find the first quartile, Q1, for the time that students spend with a math tutor. Who remembers what Q1 means? What does it even mean to say Q1 or first quartile? Yeah, it means 25% probability of being less than that value. And by the way, if you have a continuous distribution, being less than and being less than or equal to are the same. If you have a discrete, it matters actually. They're not the same. So I want to give you a heads up on that. So the question is, if you can reduce a fraction, should you? If it tells you on the computer to reduce a fraction, you must. If it doesn't tell you to reduce a fraction, then you don't have to reduce a fraction. Sound good? So read the instructions. So if it says write as a reduced fraction, you need to reduce. If it just says write as a fraction, then you don't need to. Hopefully that makes sense. So read the instructions. Okay, so find the first quartile Q1 of the time students spend with a math tutor. So the first thing we do is draw a picture. And here's the picture. Again, between 10 and 120. And we know the first quartile means the area is 25% or 0.25. What we don't know is the value of x. So I'm going to put x down here and 0.25 with the arrow as the area of this rectangle. Any questions on that? And then we go and use the formula. The formula says the area, 0.25, is the base times the height. To find the base of this rectangle, we take the high minus the low, or x minus 10. The height, remember, was 1 over 110. Any questions on that? Okay, and then, whether you like it or not, we got to do algebra. So what I can do is I can multiply left side and right side by 110. Okay, and I'm gonna switch the equality sign the other way, which you're allowed to do with equals. So we get x minus 10 equals 0.25 times 110. And I want x by itself. I have an x minus 10, so I add 10 to both sides. And I get x equals 0.25 times 110 plus 10, which is 37.5. So what we can say is that 37.5 is the first quartile of the time students spend with the tutor. Any questions? Any questions on this example? I do want to give you that big warning that it's a lot easier to watch me do it than to do it yourself. But it does help to, take notes so you get used to writing as you're watching me do it, so that when you do it, you'll be able to do it. Okay, so that's part of it. Taking notes is really important because that'll help you get used to doing it instead of getting used to watching someone else do it. Any questions on that idea? Okay, and that's just really important for learning, is taking notes helps a lot. Okay, so now let's look at the next example. So let's suppose that a statistics instructor will be giving extra credit to the students in the top 8% based on how long they spend with a math tutor. At least how long must a student spend with a math tutor to get the extra credit? Okay, this actually is not that much different from the first quartile example. But now if you're in the top 8%, that means 8% are above you. If 8% is above you, how much is below you? Or how much are below you? Yeah, 92%, or 0.92 as a decimal. And we do the same thing. That's equal to base times height. And that's x minus 10 times 1 over 120. Same idea as the last one. So x minus 10 equals 0.92 times 110, or x equals 0.92 times 110 plus 10. Any questions on that? Any questions? Okay, and I'll let you do the calculation at the end. Okay. Let's see. Time-wise, maybe I'll do one. I'll let you pick a letter. First one to put it in, D, C, E, or F. I can't do all of them in terms of our time, but I didn't expect to either. Okay, F it is. What is the probability? Oh, look at that. A couple of you wanted F. What is the probability that a student spends exactly 25 minutes with a math tutor? Okay, well, what is that? We do the same idea. So now we want the probability that X equals 25. So on the graph, like over here, we went from 30 to 70. If it's exactly 25, where does it go from what to what? But they spend exactly 25 minutes, it goes from what to what? 25 to 25. What is the width or the base of the rectangle if it starts at 25 and it ends at 25? What is that base? How far is it from 25 to 25? It's 0. So now that'll be the base times the height. The base is 0. The height was 1 over 110. And I'm hoping you don't need a calculator to tell me what 0 times 1 over 110 is. Yeah, it's just 0. So the probability that a student spends exactly 25 minutes with the math tutor is 0. Doesn't mean it can't happen, but it means it's not going to happen. Put it that way, to be exactly 25 minutes, because it might be 25.0002 minutes, for example, and that's not exactly 25 minutes. Any questions on that idea? Okay, so now what I want to do, just look at, we could look at this as the example. If I wanted to find the mean of this distribution, remember another word for mean is average, what do you think I would do? What's your thought? What's your guess? If I wanted to find the mean. And again, the basic word for mean is average. What do you think I would do if I wanted to find the mean? Base times height is a probability, not the mean. So I wouldn't do a base times height. Any ideas? Add all the values. Remember, there's an infinite number of values, so you can't do that. There's a continuous distribution, so you can't just go to all the values. That's not doable. How about just take the average of these two numbers, 10 and 120, because that'll give me right in the middle. Do you see that? And when you have a symmetric distribution, the mean and the median are the same. So the median is the middle, and that means you add up 10 plus 120 and divide by 2. Any questions on that? So the mean, and remember the letter we use for the mean is mu. That's this Greek letter mu, is a plus b over 2. You add up the left and the right and divide by 2. The standard deviation, that is the square root of b minus a squared over 12. That's one that if you haven't had calculus, you have no chance of coming up with that. It's actually a lot of work. Okay, so that one you just the old trust. Can you trust me that that's what the standard deviation formula is? If you don't want to trust me, you can always look it up and you'll see that. Okay, and I'm not even going to tell you where the 12 comes from because it's very complicated. Sound good though? So there's our mean, there's our standard deviation formula. So now let's do an example. Okay, so there's a kind of long paragraph. Suppose the number of ounces of water that people drink from a drinking fountain is uniformly distributed between 1 and 8 ounces. And the number of ounces of water that students use to fill their bottles. So here's my bottle, and I had to fill it because I've drunk some of it. So I need to go fill it. So let's suppose that that is uniformly distributed between 4 and 16 ounces. Because again, not all bottles are the same. Some are bigger, some are smaller. Okay. Let's suppose that you watch Thorn take a 2.5 ounce drink out of the drinking fountain and Preston fill his water bottle with 5 ounces of water before he runs off to class. Whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? Okay, so now this is important. What does it mean to be unusually small? In other words, how do we measure how unusually small something is? And this is something that we had in week 1. Who remembers we had something that measured how unusual something was? Yeah, got the right idea, but not charts, z-scores, you call them. So z-scores. So we're going to find the z-scores for Thorn and Preston in terms of water drinking. That makes sense? And if the z-score is really big, then that's more unusual. Is that clear? And by the way, if the z-score is bigger than 2, then that means it's an outlier. If it's bigger than 3, then it's an extreme outlier. Any questions on the strategy here? Okay, so we want to find the z-scores. And now, just a reminder, the formula for z-score was z is equal to x minus mu over sigma. Any questions on that? So I think the best thing to do is just look at one person at a time. And by the way, Thorne and Preston, a long time ago, they were my students. So I use their name because kind of cool names. So Thorne, we saw, took 2.5 ounces out of the fountain for Thorne's water. So X will be 2.5. Any questions on that? Okay, and Thorne, notice, was just drinking. Okay. Okay. So didn't have a water bottle, just using the drinking fountain. And that is uniformly distributed between 1 and 8 ounces. So then we can say mu is equal to A plus B over 2, or 1 plus 8 over 2. Any questions on finding mu? 1 plus 8 is 9. 9 halves is 4.5. And then sigma for Thorne is going to be, remember that was the square root of b minus a quantity squared over 12. So that's the square root of 8 minus 1. B is 8, a was 1. 8 minus 1 quantity squared over 12. And I put that in my calculator and I got about 2.02. Any questions on working this out? Okay, then once I did that, I just plug in z is x minus mu over sigma. X was 2.5, so there's the 2.5. Mu was 4.5. So I go minus 4.5 right here. Sigma was 2.02. So there's my 2.02. And 2.5 minus 4.5 over 2.02 is about -1. I did round a little bit. Any questions on finding the z-score for Thorn? Any questions? Okay, for Preston, we go up here. Okay, Preston filled his water bottle with 5 ounces of water. Now we're using water bottle for Preston. So first thing, Preston's X was 5. And now Preston used a water bottle. And for water bottles, that was uniformly distributed between 4 and 16. So now we find mu is 4 plus 16 divided by 2. 4 plus 16 is 20. 20 over 2 is 10. Any questions so far? Okay, we do the same thing with sigma. It's the square root of b minus a squared over 12. So square root of 16 minus 4 squared over 12. And I get about 3.46 when I put it in my calculator. And then we pop that into the z-score formula. Z is x minus mu over sigma. X was 5. Mu was 10. And sigma was 3.46. 5 minus 10 over 3.46 is negative 1.45. Okay, so again, we want to find out whose water usage was more unusually small. So was it Thorn or Preston who had an unusually small amount, a more unusually small amount of water usage? Remember, unusually small means the z-score better be farther from zero. No, it's farther to the left. Yeah, Preston. So Thorn was -1. Preston was negative 1.45. Negative 1.45 is farther to the left than -1 is. So that means Preston's water usage was more unusually small. It doesn't mean that Preston used less water, because Preston used 5 and Thorn used 2.5. It means that if you compare to the type of usage, Thorn was more unusually small. Any questions at all on using the z-scores to understand how unusual something is and using the formulas for mu and sigma for a distribution that is uniform? Any questions at all on that? Okay, so Preston's water usage is more unusually small. Okay, what's the last thing we need to do? What haven't we done yet? Right, if you don't know, the secret word. So the secret word is yes. And the reason I'm letting the secret word be yes is that if you have a binomial distribution, then you only have 2 choices. It's either a yes or a no for the answer. And again, it could be kind of yes idea or no idea. Okay, it's not tilde. I have used tilde in the past, but I didn't this time. I try to do something different every time so that you don't just like find out from someone else what the words are. So the secret word is yes. Okay, so hopefully you can remember it and hopefully you can write it down. Okay, so now I want to let you know it's 7:30. So actually, usually I'm not this exact on how long it takes to finish. But I've pretty much finished everything we need to say. but I'm always happy to answer questions. That could be with a project. It could be about the homework. This is an odd week, by the way, which means, so it's week 3, which is an odd number. So no exam this week. So that means definitely spend time in your project because you have a little less to do this week because there's no exam. So, um, but I'm always happy to answer questions. So what I'm going to do is I am going to stop the recording and stop the share and then answer any questions you might have. So let me do that.